Welcome and thanks for standing by. All participants are currently in a listen-only mode for the duration of today's webinar. Today's webinar is being recorded and will be posted publicly. If you have any objections, you may disconnect at this time. I would now like to turn this session over to your host from the United States Census Bureau, Mariana. Mariana, you may begin.
Thank you so much, and good afternoon, everyone, and thank you for joining us today. My name is Mariana McKay, and I'm a survey statistician with the American Community Survey Office here at the Census Bureau. With me today is Tyson Weister from the Center for Enterprise Dissemination. We are excited to have you today as we dive into an introduction to the American Community Survey Public Use Microdata Sample. I'd like to remind you again that today's webinar is being recorded. If you would like to follow along with our webinar today, we have posted the slides online for this webinar. The slides are available at the link you see at the bottom of the slides, as well as in the chat. If you have any questions during the webinar, please post them in the Q&A feature here in WebEx, and one of our team members will try their best to respond as quickly as possible. So let's go through today's roadmap. We're going to start by going over some basics to get you familiar with the ACS and the PUMS. We will then go over PUMS geography, specifically the public use microdata areas, or PUMAs, and how to find them. I'll then share how to find your way to PUMS data, and then I'm going to turn it over to my colleague Tyson, who's going to share how to access PUMS data through the Microdata Access tool. We will then wrap up by sharing some resources for learning more. So the American Community Survey is the premier source of detailed information about the nation's people and housing. The survey samples about 3.5 million housing unit addresses each year. These data are collected continuously throughout the year to produce annual social, economic, housing, and demographic estimates for communities throughout the 50 states, District of Columbia, and Puerto Rico. The estimates cover more than 40 topics. The ACS collects this detailed information each year that was previously collected by the decennial census each decade. ACS data are timely because they are released the following year in which they are collected. The ACS creates period estimates, which means they represent the characteristics of the population and housing over a specific data collection period. The ACS releases estimates for 1 year and 5-year periods. The ACS was fully implemented in 2005 after years of extensive testing. The first ACS 1-year estimates were collected in 2005 and released in 2006. The first 5-year ACS estimates were collected between 2005 and 2009 and released in 2010. By the way, if you didn't know this, this is the 20th year of the ACS. So the ACS collects data across 4 key categories that I've already mentioned: social, economic, demographic, and housing. Social characteristics include topics such as education, language spoken at home, and veteran status. Economic characteristics include such topics as commuting to work, employment status, and income. The ACS also collects basic demographic characteristics such as sex, age, race, and Hispanic origin. Housing characteristics include topics such as computer and internet use, housing costs, and new topics that were added in 2025 include electric vehicles, solar panels, and public sewer connectivity. Data for these 3 new topics are planned to be released in 2026. So these topics are used to produce more than 1,000 tables for local communities each year. I'm now going to ask you to think about a few things here as I introduce this data product to you. So what are your main goals when you're accessing ACS data? Are you primarily accessing pre-tabulated estimates? Are there a few variables within a single table that you find yourself going to more and more? What about the variables across different geographies or across years? How do you primarily access ACS data? Are you using data.census.gov or a third-party tool? What do the data look like on a day-to-day basis? With the tool or tools you are using, what limitations do you face accessing ACS data? These questions might have different answers depending on the data you need, so in some cases, the data and the tools we are about to explore today will be the best option, but other times another method might work better. So being able to answer these questions I asked here can determine if creating your own tables with PUMs is a good option for your needs. I always check data.census.gov to see if there are any pre-tabulated estimates for the data product and geography of interest. But in cases that I need something a little bit more specific, I'll hop over to the PUMs. So for example, today, I'm curious about poverty by age and sex for those with less than 200% below the poverty level. I know I can find tables about poverty status by age and sex, but the specified levels of poverty are not available within the same table in data.census.gov. But luckily, PUMS is going to be able to get us that table with what I want. So now it's time to get into the basics of this public use microdata sample, which I have referred to here several times as the PUMS. So the PUMS is a publicly available subsample of ACS records. One-year PUMS estimates are a subsample of data collected over a calendar year and constitute approximately 1% of all U.S. households in total, whereas the 5-year PUMS combines data collected over 60 months and constitutes approximately 5% of all U.S. households. Additional restrictions are added to protect data confidentiality, such as including broader categories of data or grouping together extreme values. PUMS files allow data users to calculate their own estimates and margins of error that may not be available in pre-tabulated products on data.census.gov. Statistical software is recommended when working with PUMS data unless you are working with our microdata access tool on data.census.gov. Not to spoil any surprises for you all, but this is the tool that my colleague Tyson is going to be sharing with us in his demonstrations today. So ACS data products are released about 1 year after the data are collected. So the 2024 ACS 1-year PUMs were released in early December, and the planned release date for the 2020 to 2024 ACS 5-year PUMs is in a few short weeks on March 5th, 2026. So why use the PUMs? So consider this table, which is titled Detailed Occupation for the Full-Time Year-Round Civilian Employed Female Population 16 years and over. To create the categories shown in this table, the Census Bureau uses responses from a combination of multiple questions on the ACS that ask about occupation, employment status, weeks worked, hours worked, sex, and age. However, you may be interested in data for individual occupations or customizing your own groups. The Census Bureau produces PUMS files precisely so that data users with varying needs can conduct their own analysis. Specifically, the PUMS allows you to create custom tables to get a greater level of detail than what the standard tables offer, create new variables using unique combinations of person and/or household variables, and conduct sophisticated statistical analyses that allow you to analyze the relationship between variables. So let's recap with an example of this microdata and what makes it different from pre-tabulated estimates that you might see in data.census.gov or other sources. So in pre-tabulated data, the data table shown here on the top from data.census.gov, individual records are categorized and weighted to create an estimate for the larger population. For this example, statisticians at the Census Bureau have taken the records of all respondents living in Montana who indicated that a male in their household works as a software developer or programmer, grouped them together, and weighted them to create an estimate of all the males in Montana working in this occupation category. These statisticians have also calculated and provided the margin of error for this estimate. By contrast, the microdata below provides a sample of those records that the statisticians used. Here, you can see that one person who responded to the ACS in Montana is a male computer programmer. To create an estimate, the data user must take this raw data and follow the same process that the statisticians did in the example above it. So as I mentioned in the previous slide, PUMS data provide individual records that data users must aggregate to form estimates. Unlike in data.census.gov, there are no pre-tabulated data. Weights are included on the PUMS files so that data users may create weighted population estimates. If you are working with housing records, you will use housing weights, and if you are working with person records, you will use person weights. When working with a merged file that includes both housing and person records, person weights should be used to produce estimates for person characteristics. Housing characteristics cannot be tallied from this merged file without taking extra steps to ensure that each housing weight is counted only once per household. Replicate weights, those numbered 1 through 80, are used for calculating replicate estimates needed to calculate standard errors. Standard errors using replicate weights are necessary to calculate the associated margins of error. So another feature you're going to see in our data products in pre-tabulated estimates is the inclusion of that margin of error, or MOE, next to each of the ACS estimates. Because the ACS is based on a sample, ACS estimates have a degree of uncertainty associated with them called sampling error. To help users understand the impact of sampling error on data reliability, we provide a margin of error for each ACS estimate. Margins of error allow data users to be certain that, at a given level of confidence, the estimate and the actual population value differ by no more than the value of the margin of error. The Census Bureau uses a 90% confidence level as its standard. So all ACS estimates published on data.census.gov have margins of error calculated at that 90% confidence level. So it's also important to note that the margins of error provided by the Census Bureau are always in the same units as their respective estimates. For instance, a percent estimate will have a percent margin of error, and a median income estimate is going to have a margin of error in dollars. So here on the screen, we have a typical table, subject table S0101, age and sex, as it is displayed on data.census.gov for the state of Mississippi, using 2024 ACS one-year estimates. I have the row I'm going to work with here highlighted, but let's go over the basics first. So as you can see, the table has 3 elements. So it's the characteristics, so that's the descriptions. We have the state, we have percent male, total population, and under 5 years. We have the estimates, and then we have the accompanying margins of error. So put simply, the margin of error is a measure of the possible variation of an estimate around the population value. So in this example, we want to know the percentage of males under age 5 who live in Mississippi. We find the lower bound by subtracting the margin of error from the estimate, and similarly, we find the upper bound by adding the margin of error to the estimate. So we are 90% confident that the true percentage of males under age 5 in Mississippi falls between the lower bound of 5.5% and the upper bound of 6.1%. So I did mention that the 2020 to 2024 5-year PUMs will be released in March, but let's unpack this PUMs product briefly. The 5-year PUMs is the equivalent of 5 one-year files, so it includes about 5% of all U.S. households. But people often ask, what is the benefit of the 5-year PUMs? There are some nice standardizations for the 5-year PUMs that you can't necessarily get by merging 5 one-year files. For example, new weights are produced for these records so that the weighted population matches the latest population estimate. Dollar amounts have an adjustment factor to standardize them to the latest year so that no one is comparing varying levels of inflation. Other coding schemes are updated, such as ancestry and occupation, so you don't have to recode those yourself. If you're interested in an example of how PUMs can be used in action, you can visit an interactive data visualization we released on young adults in higher education. We use the PUMs here rather than our internal microdata to showcase the sophistication of what can be done using the PUMs. We went through the same steps any data user would to aggregate the data and calculate associated margins of error using replicate weights. The results were an interesting story on what degrees young adults are getting and what those degrees are doing for them in terms of occupation and earnings. So this is not an analysis that could have been conducted only using our existing tables. Now that we've covered some basics, we can dive into PUMs geography, which might be a little different than the geography that you're used to. So to ensure the confidentiality of the ACS respondents, the Census Bureau has to balance geographic detail with detail in the data. There are more than 250 variables on a single PUMs person record. This means that we cannot identify as many small geographies in the PUMs as users might hope. We can put the region, division, and state on the file, but the only other geography is something called the Public Use Microdata Area, or PUMA. PUMs is not designed for statistical analysis of small geographic areas, but the PUMAs can still be used for focused analyses in counties and cities of 100,000 or more people, as well as many metro areas. And I'm going to show an example of this shortly. but I'm going to spend a little more time here on PUMAs. PUMAs are areas within a population with a population of at least 100,000, which is large enough to meet disclosure avoidance requirements here. PUMAs are identified by a 5-digit code that is unique within each state. These geographies are redefined after each decennial census and are defined by either the state data center or, in some cases, the Census Bureau's regional geography staff. 2020 PUMA definitions were introduced with the 2022 PUMS files. As with many geographic concepts, seeing PUMAs on the map may help you understand them better. So as you can see here, some PUMAs are small and others are large, again, because PUMAs are built on population, not geography. So the smaller PUMAs here are mainly concentrated in the Buffalo and Rochester regions of this map. I want to highlight 2 tools to help you determine what PUMAs you might need. The first is from the Missouri Census Data Center, which has a fantastic geographic correspondence engine that you can use to match PUMAs to other geographies of interest, which is one way to figure out what PUMAs you might need. GeoCore is also a good tool for crosswalking PUMAs with other geographies. Census Academy has a brief 7-minute tutorial to walk you through using GeoCore, this tool, complete with a demonstration on converting PUMAs to counties and vice versa. The link can be found at the bottom of the slide. Another great tool is using data.census.gov, which has the ability to visualize geographies. So this screenshot shows the PUMAs that make up Fresno County, California. If you look closely, you can see that there are 7 that make up the county, so you can combine data from all to approximate estimates for the county. The primary difficulties occur when we get further away from urban centers to counties with smaller populations, which are then combined with other counties to make PUMAs. So in these cases, it becomes less feasible to be able to infer data about the individual county. Furthermore, while I am showing an example here of PUMAs adhering to county boundaries, it is not a requirement that PUMAs be designed that way, although it is recommended. So some of you here might know that data.census.gov has an address lookup option in the search bar. I just want to let you know that right now the PUMA geography does not pop up when you use that option. So now that you know about PUMS data, we can start to look into ways to access it. One of the most common ways to access PUMS data for use with statistical software is through our File Transfer Protocol, or FTP site. So we do have a dedicated webpage on the ACS website for the ACS PUMS. Here you can access PUMS data, documentation, and other resources. You can navigate here by going to census.gov/ACS and then clicking on the Microdata tab in the left navigation bar. So the Microdata section is where we will start our search for PUMS data. And to begin, we will go to the PUMS data highlighted in red on the left navigation bar. So this slide highlights the steps you will take to download the PUMS files from the FTP site from the Accessing PUMS data page. So once you navigate to this page, select the year you are interested in and from the year tabs on the page. Then under heading Access on the FTP site, you will decide whether you want the 1-year or the 5-year. From there, you will see a list of files with a naming convention that identifies whether the file is in CSV or UNIVAX form, whether it is housing or population files, and whether it is a file for the US level or an individual state. Not to be a broken record, but again, the 2020 to 2024 ACS 5-year PUMS will be released in a few weeks, so you are going to be able to access both the 2024 1-year and 5-year PUMS data from this page. So as you can see, there is also another way to access the data besides that FTP site. Admittedly, this method is the main way I personally access PUMS data. So without further ado, I'm going to now pass the torch off to my colleague Tyson to share how to create custom tables in data.census.gov using the MDAT tool. So this is the method that requires no statistical knowledge of statistical software in order to create your own custom tables.
Awesome. Thank you, Mary. And we'll get back here to the slides and great. Go to the live demonstration. Thank you all so much for spending some time here to learn how to use the Microdata Access tool with all of the information Mary gave about the American Community Survey PUMS. I'm going to show you how to access it. And what I have planned are a demonstration with 2 different examples. So we're going to start out very basic in our first example, and then we're going to layer on additional functionality and features to show you how to do more complex types of things on our site. So with that, we're going to start with our first example, looking at health insurance status for women who gave birth in the past year for all states. This is going to show you how to select variables, limit the universe, and save your results. Mary hit on this a few different times. She always goes to data.census.gov first to see if there's a pre-made table that covers the analysis that we're looking for. So this slide is me just showing that I did a little bit of research beforehand. I looked at the pre-made tables on the site. I found table on the left-hand side for fertility. It shows data for women who gave birth in the past year. And then I found a table here in the middle that shows data for health insurance status. So that breaks out the information for these 2 concepts separately, but there is no such pre-made table that shows health insurance status broken out by women who have given birth in the past year. So with that, it is a great opportunity to go to our site and create a custom table. So step by step, I'm going to be walking through different clicks. We've mentioned that slides are available for you all to access. They will show all of the clicks that I'm making today. So if you miss a step as I'm going, don't get worried. You'll have that as a resource to look back to. When you're here on our landing page, what you'll want to do first is click Microdata at the top. Once you click, you'll be taken to the Microdata Access tool on data.census.gov/MDAT. And what we're going to be doing is working step by step through the different tabs here. So starting with dataset and one at a time, getting to the custom table display that we'll be creating. Here on the dataset section, it's asking us to choose the dataset and the year that we want to work with. So first, I'm going to click and you can see different data sets. The ACS ones happen to be at the top of the list. And I'm going to be working with the ACS 5-year estimates, public use microdata sample. The reason for this is just to have the data in these custom tables based on more survey responses. Once you've selected a data set, it's going to put you in the most recent available data by default. As Mary mentioned, the 2023 ACS 5-year PUMS is the most recent for that vintage, and the 2024 will be released shortly. So here I'm going to go ahead and click Next, and that's going to take us here to our Variables tab. So there are over 220 different variables from this data set that are immediately displayed on the screen that I can scroll through and select. You'll probably want to narrow that down a bit. And I'm going to show you one way that you can go about doing that. You'll notice that there are search bars at the top of all of these options. So where you see the column for label, I'm going to click there. And what I like to do is just type in a keyword. So for instance, health. That is going to give us a list of all of the variables that begin with the word health. So we can see here there are 6 different variables to choose from. The very first one in the list, health insurance coverage recode, looks like it would have what I want. Before I ever select a variable in MDAT, what I always do is look for the chevron to the left of the variable name. So here we have HiCove, the chevron, and when you expand that, what you'll see is the site will tell you what values this variable measures and what you can create a custom table out of. So it provides exactly what I expected it would. Data for people with a value of 1 representing that they do have health insurance and a value of 2 representing that they do not have health insurance. So this is exactly what I want. You'll just mark the checkbox to the left to register that as a selection, and notice that our data cart now has 1 variable in it. And what you'll do is just repeat this process to select all of the variables that you need for your custom table. So deleting health out of that variable label box, here I'm going to type in my next keyword, which is birth. It brings up 4 different options. And I can see here the second one says gave birth to child within the past 12 months. It says there are 3 response categories for this particular variable. And I always click the chevron and see what those 3 categories are. So in this case, it says a value of 0 means not applicable. So it might represent someone who's under 15 years old, greater than 50 years, or someone who's a male. A value of 1 to represent a woman that did give birth in the past year, and a value of 2 to represent a woman who did not give birth in the past year. So that's the variable I want. Again, check the box to the left of FER, and we see in our cart, we now have the 2 variables that we want and need, health insurance and fertility status. So now at this point, I'm done with the variables tab, and I'm going to move to geographies. So I wanted this data at the state level, and to get the data for all states, you can see the available geographies are here in these tabs at the top. You can click state, and we have a variety of options to select geographies conveniently, both as individual geographic selections and a select all button if we want to choose all states in one click. So here I've made that selection, and we can see we've selected all 50 states plus the District of Columbia. I'm ready to move to my next tab here, so I'll click the cart. This is where you'll want to review the variables you've selected. So on the left-hand side, I have a variable for health insurance status. I have the variable for women who have given birth in the past year. The other thing that you can do that I'm going to show you with this first example is you can limit the universe or population that your table represents in this step. So it's an option for you to simplify the view of your table before you go to the table view. So in my instance, I just want to look at data for women that have given birth in the past year and then see whether they do or do not have health insurance. So with fertility selected, if I want to exclude other populations from my table, I just uncheck the box for not applicable, uncheck the box for no, a woman that did not give birth in the past year, and leave the box for the particular variable value that I'm interested in for my analysis. So by unchecking those boxes, we have removed them from the universe of our table, and we're ready to go ahead and create that custom table. So once we do, we just click table at the top. It is pulling all of the data in real time and feeding it on your screen. So we'll give it a moment to load here. What I wanted to mention on the left is you'll see that there are different boxes that represent each of your variables, your recoded variables, if applicable, and your geographies. So you can drag and drop these in different placement between the columns and rows. And it's mostly aesthetic. So as long as you have the same 3 variables somewhere in the columns and somewhere in the rows, you're going to get the same data on your screen. It's just going to be laid out in a slightly different order. So I'm actually going to leave for this particular demonstration the default selected and just leave the variables placed as is. And then here, I'm going to go ahead and just confirm a few things on the left. It's showing data for count, so we're getting data for the total number of people. We can see that it's people because the site has automatically applied the person statistical weight and taken these survey responses so that they represent the total number of people in these geographies that meet the conditions shown in our table. And then we'll notice here on the left, there's another option to switch between different vintages. So I'm going to leave everything as it was by default, and then just take a quick readout of the table before I show you some more things. So here we can see, we'll zoom in a little bit more. You'll want to read out your columns and rows so it provides data for health insurance coverage status. Yes, with health insurance, and no health insurance. And then remember, we limited the universe of our table to only show data for women that had given birth in the past year. So we're getting that as well, just laid out here very explicitly with these two labels below. So what this is telling us when we look at Alabama, we can see that there were an estimated 51,501 women who gave birth in the past year that did have health insurance, and then 7,260 that did not have health insurance. So that's what we're getting, the difference between these two columns. And then the total women who had given birth is summed up for us here in this particular row that says total. You can also click the column headers here and sort the data in ascending or descending order. So for instance, I can see with just a few clicks that the top 5 states for women who had given birth in the past year that do not have health insurance in terms of totals is Texas, Florida, California, Georgia, and North Carolina. Now, once you've gone through these steps, you'll likely want to save all of this work that you've done. We make it easy with different options from download, share. Before I get there, I just want to review the View Universe button here. This is just another option for you to confirm what is included and what is not included in your table. You'll see a summary of all the geographies that you selected first at the top, and then you'll notice here below that in this case, we have restricted the table to only show data for women that have given birth in the past year. So just a little reminder for you there. And then moving on to saving the results. Right beside View Universe, you'll see Download, Share, and a few different options. For today, I want to show you an export of the table data. So we'll notice here at the top, table data format. You can choose Excel or CSV. I'm just going to use the default, export it, and open up that file. You're going to get something that looks almost identical to what you see on screen. You will see the table universe statement first, so you may need to scroll down a bit. But once you get there, you'll notice that you see the same data that we saw in the table display right here, and it even captured the fact that we had sorted the one column. One thing that you may have noticed is that we're getting just totals. If you wanted to calculate any percentages, we don't have the functionality to do that directly on the Microdata Access tool, but you can export it and do those types of things very quickly here. And maybe this would give you an analysis that may be more useful. It's not too surprising to find out that states with large populations like Texas, Florida, California would have some of the highest numbers of women who had given birth in the past year without health insurance, and maybe percentages are more useful to you. So we encourage you to output the data and use your analysis capabilities further. Mary had shown some different raw data. If you wanted to download the individual records that these statistics were based off of, that's what the raw data format is. I'm not going to show it, but just pointing out that it is available to you to download. And then when you go over to share, you get more options. One is a URL that takes you back to the same table. So if you share it with a colleague or visit it later, it's going to take you to MDAT with the same variable and geography selections. It'll take a moment to load because it's pulling it all fresh from real time, but it's the same as what we just saw. There are also API queries. This is just another way to get information from the Census Bureau. Our application programming interface is public. The API GET query is going to get you the raw data, okay, those individual records, and the tabulate query is going to get you the custom statistics that we're seeing in the table display. So I have the GET query here loading in the background. And one other thing I wanted to show you on the table display while it's loading, there is the ability on the left to switch to unweighted counts. So for instance, what we're seeing now in the table is statistics that represent the overall population. We don't have the ability on the Microdata Access tool to get or calculate standard errors or margins of errors associated with these estimates. You can, as a data quality measure, click over to unweighted, and that's going to give you a sum of the total number of individual records that each cell in your table is based on. So for instance, this tells us that this particular table cell is based on 48 microdata records. So just an important option for you to get that quick data quality measure. And then back here, showing you the raw data. Now that it's loaded up in the API, this was the API GET query. If you'd like to download individual records for the edited survey responses that are powering your data, they're available to you in multiple formats. The way you would read this particular one out is we see PWGTP, that's the person weight, ICOV value of 1. So this particular row of entry is representing someone who did have health insurance, someone with a fertility status code of 1, so a woman who did give birth in the past year, and someone with a state code of 36, so a woman that live in the state of New York. And because the person weight is 20, this particular survey response represents 20 other women just like her. All right, so that's going to wrap up our first example. We chose some pretty basic variables to work with and really showed you how to go about the process from beginning to end and download and save the results. What we wanted to do in our next example is dive a little bit deeper and show you how to work with numerical categorical variables. So again, before we get to our demonstration, you always research the pre-made tables first to make sure there's nothing already created that meets your needs. In this case, I found a table that provides poverty status in the past 12 months by sex and age. It provides certain age breakouts, but maybe they're not the exact age breakouts that I want for my analysis. Maybe I want to know the number of people aged 5 to 9 years old that live in poverty, and this table breaks that out a little bit differently. In that case, it would be a good use for you to create a custom table. So we're going to show that poverty status broken out by sex and age for custom age groups, and I'm going to use a smaller geographic area, public use microdata areas in Fresno County. So back here to our site. At the moment, the easiest way is to just return to data.census.gov/MDAT or click the microdata tab on the landing page. Once again, I'm going to use the ACS 5-year estimates, and hopefully me showing unweighted counts was of use to you. What I can say, anytime you use ACS 5-year estimates, you're going to get unweighted counts that are always greater than or equal to unweighted counts from ACS 1 year. And you would expect they would be greater than in almost every case. So it just gives you more survey responses to generate that estimate. So again, using ACS 5-year and clicking next, we will go through some of the steps that we did before. I'm going to show you additional tips. One way I like to select my variables beyond this search box is to use the drop-down menu, filter by topic. We can choose age and sex, and it gives us the 2 variables for age and sex. Again, we'll click the chevron to the left of sex, see that it provides the data categories that we think it does, and we'll do the same thing for age. What I wanted to highlight here is that this is a continuous variable. So anytime you see in one of these bullet points a range of values, so we see 1:99, and then we see the word 2 as well, it's telling us it's a continuous variable. We also give you an indication on the site when you select it that the variable is continuous. And what this message is saying is that you're probably going to have to do some work in the data cart in order to actually use this variable in your table. So another way of putting this, the site has no default as to how you want this variable defined. And unless you tell the site how you want this variable to appear in the columns and rows of your table, we aren't going to do anything with it at all. So I have age and sex. I'm going to click filter by topic. We see all these different keywords that are handy. including poverty. So when I choose poverty, we see there's one variable. It's income to poverty ratio recode. I click the chevron and it tells me the person's income as a percentage of the poverty level, from 0% all the way up to 501% or more of the poverty level. So I'll go ahead and mark the box. We get the message that this is a continuous variable, so I know I need to do some work in my data cart. Moving on to the geography, I have my three variables, poverty, age, and sex. Clicking geographies at the top. In this example, I wanted to use PUMAs. So when you click PUMA, it first prompts you for the state. We wanted the ones in Fresno County, California. Each state has different kind of names for their PUMAs. In California, they tend to be named by the county level, which is pretty common, but not 100% across all states. So we have a little handy check or search bar here at the top where I can type in Fresno. It shows me the 7 PUMAs that make up Fresno. We saw that on the map earlier when Mary was showing her slides, and I can select all 7 of those. If I don't do anything else, I'm going to get data for each of these 7 PUMAs individually, and if I wanted data for the county, I would have to manually add that together. If you use this group functionality, we have a feature on the site that will add up that data for you automatically. So you're going to get a section in your table that has the data combined for you. We call this grouping or aggregating geographies. So what you'll do first is select your individual geographies. When you're in the group tab, you'll just make sure to choose the ones that you want to group together. Here I want all 7 PUMAs, and I'm going to click Create New Group. On the right-hand side of the screen, we see those PUMAs. You can create your custom label. So here, this will represent data just for Fresno County, add it up. So I went ahead and typed that in as the label. It's an optional step, but just ensures that there's a column or row in your table with that label. Moving on to the cart, I have the sex variable. And next I'm going to go ahead and start doing some groupings. So here for poverty, I'm going to click Create Custom Group. And you can specify different categories of your table. So what we can do is create a group for people that live in poverty. So I'm going to put income below poverty level. Someone whose income is below the poverty, they would have an income from 0 to 99% of the poverty level. So first I just uncheck the boxes that don't apply, click the pencil icon, and then change the maximum from 500 to 99 and click Save. So I have a label I've typed in. Below I have values that go along with the label, and then we'll click Save Group at the top to complete this step. So with that process, I have my recoded variable. I have the first recoded value that I've specified, and everything else for poverty that I didn't tell the system what to do with, they've grouped into a section called Not Elsewhere Grouped. So what you'll do is look for the pencil icon for Not Elsewhere Grouped. You'll click into it, and then you'll go through this process to spell out exactly how you want to define everything. So for my next variable, I'm going to put income at or above poverty level. I'm going to uncheck the NA box and just leave these 2 values selected. So this is people who have income 100 or more % of the poverty level. Click Save Group. And then this last category, you can just kind of leave it as is. You can put a special label in if you want. I'm just going to put NA and click Save Group. Similarly, so this was one of our continuous variables. You'll do the same thing for any other continuous variable. In this case, I can do this for age to create those custom age groupings. In the interest of time, I'm going to go through this a little bit quickly here. 0 to 4 is my label. And then I'm going to assign the values that correspond to that. Click Save Group. I have my first option here, and I'm just going to repeat this process for 5 to 9. We'll do it again, 10 to 14. And again, you'll have step-by-step slides if you'd like to reference this process later. 15 to 17. And then I'll do 18 and over. Once you're finished, again, kind of review the labels that you manually typed. Make sure you assigned the correct values to those labels. And just review on the left. We have a recoded poverty variable, recoded age and sex. I'm ready to view the table. When you recode variables, the site will put them not in the table. You probably want them in the table. That's why you went through the steps to recode it. So you'll need to manually drag those up to the columns and rows. So I'm just going to drag this particular table to the specifications that I'd like, geographies and sex in the column, and our recoded age and poverty in the rows. And then it has provided data for the total count, and it's applied the person weight. So reading out this data, you'll want to pay attention to the columns and rows in the table display. You'll get data for each of the 7 PUMAs individually first. And then at the very end, because we went through the steps in the geography tab to group, you'll see our custom group is there. We have data added up for Fresno County automatically. And then we see the data here. So for instance, if we look at the total 5 to 9 age category, we can see income below poverty level, that there are 20,679 children age 5 to 9 in Fresno County that live in poverty. Approximately 10,341 are male and 10,338 are female. And that's going to wrap up the last demonstration here. One final note that I wanted to mention, we talked a little bit about weighting in our demonstration. We always went with the default weights that were automatically applied. There are cases when you will want to review the default weight and potentially change the default weight. So we have a very high-level FAQ that describes this in general. Which statistical weight should I apply in the Microdata Access tool? And then we've also written one specific to the American Community Survey. Should I apply the person or housing weight in the Microdata Access tool? This will tell you the specific situations when you would need to manually change it and how that, how the weight that's applied changes your readout of the data values that you're seeing. So we hope you take these resources as well for your MDAT needs, and I will turn things back over to Mary. Thank you so much.
Thank you, Tyson. All right, so I just want to wrap up by sharing some ways to find out more and to stay in touch. So if you're like me, I do my best learning when I am practicing. So today, Tyson and I just graced the surface of PUMS, and I like to follow along with webinars and workshops that have some activities to check my progress and my understanding. So I put together a list here of videos to see step-by-step directions for various aspects of the MDAT tool that Tyson just went through. The data gems are going to be shorter, more brief videos. And Tyson's teams conduct live workshops that go in more depth when it comes to using the MDAT tool. So do yourself a favor and check out future dates to sign up and get your hands dirty with PUMS data. The PUMS documentation page has all the resources you will need for every data release. And I think another great resource that we spent a lot of time perfecting is the PUMS Data User Handbook. So much of the information you heard from me today can be found in that handbook. It's understanding and using American Community Survey public use microdata sample files, what data users need to know. And this is part of a series of data user handbooks on our website. We have versions of this handbook for general data users, state and local governments, businesses, and more. So all of our handbooks can be found at the link listed below. I want to point out a few specific resources for you to bookmark as you are continuing or beginning your PUMS journey. So we have gathered several materials to creating custom tables in data.census.gov, and some of these include step-by-step guides created by our developers and subject matter experts. So let me finally highlight a page I mentioned a few slides back, that PUMS documentation page. So if you navigate to the PUMS documentation tab in the microdata section, you will find supporting documentation that is released with each new dataset. So on the PUMS documentation page, you will find the resources listed on the slide for each data year released, including user guides, data dictionaries, code lists, and more. So we update these documents for every PUMS data release, so you have access to the most up-to-date information. In closing, I encourage you to connect with us directly. So if you have ACS or data.census.gov questions, you can reach out to us at the email addresses or at the phone number shown here on this slide. I have also provided the link to sign up for and manage alerts about both ACS and data.census.gov here. And one last thing, if you're using the American Community Survey, please make sure to source the Census Bureau's surveys as to where you receive the data. It helps people know that the information they're using is powered by the American Community Survey. So this concludes today's webinar. We thank you for your time and attention and have an awesome day.